Hello, welcome back to our channel. I am Anisha, your maths faculty for class 12th. We are doing chapter 5 of your NCERT book, that is continuity and differentiability. And in this chapter, we have completed our introduction video. After that, we have started solving each and every questions of our textbook, in which we have completed our exercise 5.1. And as you can see in the title, we are doing exercise 5.2 this time. And so motto for today's video will be we will cover question number 9 and question number 10 of this exercise 5.2. Let's move ahead in this video, and our main aim from this videos is to learn the maths in as simple as we can. Okay, so let's start. So this is our question number 9 of exercise 5.2. Let's read the question. So in this question, what we have to do, we have to prove the function f, which proof the function f given by, so that f is given as mod of x minus 1, where x belongs to real. We have to show it is not differentiable at x equals to 1. Okay, so always write the given, as I already told you in my, as you can, if you have seen my previous videos or whatever it is, but I am telling you once again. So always write what is the required condition, sorry, what is given to you and what you have to do. So there will be a roadmap for you how to proceed. So therefore, first we write our given condition. So in given condition, what we are given, that we are given our function f of x. So our f of x is defined as mod of x minus 1, where x belongs to real number. Okay, now to here we have to show, or we say we have to prove. What we have to prove, that our function f is discontinuous, sorry, not differentiable, at x equals to 1. So now let's proceed for that. As you know, so we only have to check the differentiability of the function at x equals to 1. Let's proceed with that. So for that, as you can see, I always have told you, when you have a mod function, there is an important funda. What is that funda? That is no star. If I want to change, always like important, yes, important, sorry for the language. Yeah, it's important that when you have a mod function, if your x is a mod function, always simplify that function as much as you can. So as it is mod of x minus 1, so it can be written, if my x is less than or equals to 1, then your function will be minus of x minus 1. And if your x is greater than 1, then your function is defined as x minus 1. This is your function f of x. Now let's check the differentiability. Now it will be a piece of a cake for you, or very simple, very simple now to do. Okay, so we have to, what we have to find? We have to check the differentiability of the function. So for differentiability, what we will do, we will find, as we know, we will check the differentiability of the function. First we find our left hand derivative, then we find our right hand derivative. Then if they both exist and both are equal, then we say the function is differentiable. So let's do what I have told you. So first of all, I will do here. First of all, we find our left hand derivative. So as you can see, our left hand derivative, we know that it is given by, we have to check it. All we have to do at x equals to 1. So what it is given by, limit of x tends to 0, f of 1 plus h minus f of 1 divided by h. We know, just put the value as it is 1 plus h, that means it is greater than greater than 1 value. So it will take the value as x minus h. The function will be x minus of 1 form. So this value will be 1 plus h minus 1. And at x equals to 1, as you can see, your function value is 0. So minus 0 divided by h, where it is limit of h tends to 0 positive 0. So this will be limit of h tends to 0, h by h, and we see that this is 1. So our left hand derivative is 1. Now let's find our right hand derivative. I can do it here also, here because it's quite enough big space. So our right hand derivative, that is limit of h tends to 0, we will find it as f of 1 minus f of 1 plus, sorry, f of 1 minus h, right? Sorry, by mistake. Always if there is a, if you have to find the derivative, right? So what you do is find your left hand derivative separately, find your right hand derivative separately, then equate them. Okay, so this will be this is left hand derivative, then right hand derivative divided by, this will be h. So it is a limit of h tends to 0, 0 minus, as it is 1 minus h, so its function value will be this. So this will be minus of 1 minus h minus 1 whole divided by h. So this will be limit of h tends to 0. Okay, let's do it in next page. Okay, so because it will be like becoming beside my behind my photo, so let's do it in next page. So this will be, this limit will be this minus cancel, this will be minus h by h form. So this our for continuing with the right hand derivative, so this will be become limit of h tends to 0 minus h by h, and this is nothing but minus 1. Okay, so as you can see, our right hand derivative is not equals to left hand derivative. Our left hand derivative is not equals to right hand derivative. This implies not differentiable at x equals to 1. So that's done. That's all we have to do. Like we have shown that our left hand derivative, right hand derivative both exist, but they are not equal. Therefore, the function is not differentiable at x equals to 1. That's all we have to prove, that the function is not differentiable at x equals to 1. Now let's move ahead to the next question. It's very quite easy question. Always like what I'm saying is, that mod function, I will give you an important conclusion, you say, or you must say it as a result, treat it as a result. The result is that when you have your function f of x, say this is of the form same mod of x minus a. So we have like come across with its continuity and differentiability both. We have made a conclusion. What is the conclusion? That it is always continuous at all our continuous, or in short, if I want to say it is, as it is continuous in all its domains, so therefore it is a continuous function, and it is only not differentiable, not, sorry, there is a mistake, only not differentiable at x equals to a. Otherwise, the function is differentiable completely on whole domain except at x equals to a, that this part. Okay, so we are done. This is like important result. You should remember this because it will help you in many MCQs forms, and like take it as learn it or whatever you have to do. Then you must know this thing, that the mod function is always continuous, and it is not differentiable only at the point where the function is like becoming 0. Okay, so now let's move to the next question. So what is our next question? In our next question, we are given the same thing. We have to do. We have our function f of x, which is the greatest, defined as the greatest integer function in the range of open interval or 0 to 3, and we have to show the function is not differentiable at x equals to 1 and x equals to 2. Okay, this we have to do. Now I am not writing the whole like a given condition. What we have to do? Well, it's on you now. Right? I am just leaving the space. What is given and what to do, it's on you. Write it by yourself, because when you do these things right, then you get the practice, you know how to proceed further, you know how to start if you are like stuck somewhere. So at least you should write your given condition and what to do. Now let's move ahead. So for first, what I will do is I will do only one part. The next part will be homework for you, because the same procedure you have to follow. So what I will do is I will say about x equals to 1, that the function is not differentiable. I will prove that the function is not differentiable at x equals to 1. Okay, so let's move there ahead. The same thing we have to do as we did in the question number 9. The same thing, you will see the same thing is repeated, just the function is changed and your values will be changed. Otherwise, the logic is always same. Okay, so for that, first we find our left hand derivative. So for left hand derivative, we have at x equals to 1, limit of h tends to 0, f of 1 plus h minus f of 1 divided by h. So this will be limit of h tends to 0. F of 1 plus h, as you can see, h is taking like coming to 0. It will take the value greater than, if you like more confused, whenever you are more confused. So what you do in your left hand derivative, I will give you like a lot of students are stuck at that point. What you do is find your left hand derivative and right hand derivative taking the limit h tends to 0 positive. Okay, always this will work. There is like because what you are doing is I already told you in the introduction video also. So whenever you have to find your left hand derivative and right hand derivative, the limit you will use is limit h tends to only 0 positive. Here also you will use limit of h tends to only 0 positive, because the other work what we have to do is like come in this parts. Okay. So for that, this is limit of h tends to 0 positive. So this is like greater than 1. Okay, 1 plus h, you are approaching your 0 from the right hand side, so this is h is positive, so this whole part is greater than 1. So its limit value, that is greatest integer of 1 plus h minus greatest integer of 1 divided by h. So this will be limit of h tends to 0 positive, so its greatest integer will be 1 and its greatest integer is 1 divided by h. That means your left hand derivative is 0. Now let's move to your right hand derivative. So what is your right hand derivative? For right hand derivative, you have limit of h tends to 0 positive. See, what the same that the thing that I have told you. Like you have here you are 1 plus h minus f of 1, right? And here you what you take always. This is f of 1 minus f of 1 minus h. Like to take the negative of, you have taken your minus h here. So your work is done. Okay, so how we have to take the limit? Only the from the positive side. Okay, so this is f of 1 minus f of 1 minus h. This divided by h. So this right hand limit will be limit of h tends to 0 positive. And this f of 1 is greatest integer of 1 minus greatest integer of 1 minus h divided by h. This whole things are just I'm saying like it's like on you to listen it or not, because it's quite easy. So here you are coming from like left hand side, like this value is less than 1, so its greatest integer value will be 0 divided by h. As you can see, this will be limit of h tends to 0 positive 1 divided by h. So 1 divided by h and your h is going to 0. So this limit will be infinity. That means not defined, or say not exist, as your right hand limit does not exist. There is no point to now it match with your left hand derivatives. From here you can say that the function is f is not differentiable at x equals to 1, right? Okay, so done with here. Now the another step is to check to check at the function is not differentiable at x equals to 2. So this is homework for you, because the same thing you have to do, like same procedure, but here only what is changed, that only your x is changed. Instead of at checking at 1, you have to check at 2. Okay, so done. Now I think, yeah, so our this exercise 5.2 is completely totally complete now. We have like covered all each and every questions of this exercise. Keep practicing the questions. Differentiability is like quite like little bit one step ahead from the continuity. Continuity is like quite easy for you. You guys are like used to about the continuity now, because it's very easy to like it's not, I will not say it's easy, because it's not easy for everyone. It's a kind of moderate topic where you can understand, you can make things, but differentiability is like one step ahead. So keep practicing on the questions that require the differentiability, because it will help you a lot, because in like upcoming exercises we will use your differentiability and continuity, both the concepts, but you need to be clear in the concepts of the differentiability, differentiation of a function, differentiability at a point. Okay, so that's all, and please keep practicing the questions. If you have any doubt, please ask me in the comment section. I will like solve your doubt as soon as possible. And till then, goodbye. Let's meet in the next video, and please like, share and subscribe. Bye bye.